So there's another kind of asymptote called a slant asymptote. We've talked about the vertical asymptotes that go up and down. We've talked about the horizontal asymptotes that go across. But what about an asymptote that goes sideways? That's called a slant asymptote. And so here I have a function, and we want to figure out what is the slant asymptote. And then the rest of the graphing is just like everything else. So I'm not going to go over that. We're just going to go over how to find a slant asymptote. And the idea with the slant asymptote, the only way you're going to get one is if the top exponent, the top degree, is 1 bigger than the bottom. So here you see we have a squared and a 1. So 2 minus 1 is 1. So this is going to have a slant asymptote. Now if this was a 3 and this was a 1, we wouldn't have a slant asymptote because it's 2 bigger. It has to be exactly 1 bigger. And so to find a slant asymptote, what you're going to do is you're actually going to do the division that this fraction shows. See, this is a fraction, and so we're saying this divided by this. So I'm going to go ahead and divide that. So I put x plus 1 in the box, outside, and I put x squared plus 2x minus 3 in the box. Okay, and then we go through the process of dividing. So we go, what do we got here? X goes in x squared once, well, x times, multiplied by x. So x, do you know what? This isn't how we learned it, is it? No, this isn't how we learned it at all. We learned it using a box. So let's try that now. Sorry about that. Okay, so we set up a box. I know I'm dividing by x plus 1. And I need to put x squared there, right? Because I put the first thing in the box. Now to get that x squared, I need an x, and then x times 1 is x. Okay, now I need a 2x, so I need another x there. And x times 1 gives me that, so 1 times x is 1. And then I look here and I need a negative 3, so I need a negative 4 to get me that negative 3. Now this is my remainder, and here's the cool thing about slant asymptote. I don't care about the remainder. The only thing I care about is what I get before the remainder. So this is my slant asymptote. This is the part that I'm going to take, and when I graph it, I'm going to graph that it crosses at 1 and it has a slope of 1. And so this is my slant asymptote. It's going to look like this. And so then you go through all the same stuff as before. You still find your x-intercept, your y-intercept. You find your horizontal asymptote, which is not going to because it's top-heavy. And so whenever you do have a slant asymptote, it'll automatically be top-heavy. You're going to find a vertical asymptote, and then you're going to plug in points. And what's going to happen is we're going to have a vertical asymptote at negative 1. What's going to happen is your graph is going to be either in here, like this, or it's going to be out here like this. And so basically you're just plugging in values, still looking at the vertical asymptote. You're plugging in values on either side of the vertical asymptote just so you get a good idea of what it is. But that's slant asymptote.